It's time to talk about isometric sketching. Isometric is a drawing technique which allows you to draw 3D objects. Personally, I find it a lot easier than doing a perspective drawing because it requires less construction than a perspective drawing does. It requires less, if you like, step by step than a perspective drawing does. And the reason I like isometrics is because it's a super fast way to draw boxes and cubes. And as we know, later on I'm going to show you how everything, even complex curvy shapes, can be started off as boxes and cubes. So an isometric sketching technique is an excellent technique to practice and to use with a mind to moving on and doing more complex stuff. Now, as ever, you can follow along using a simple pencil, that'll be fine. My camera can't really see pencil lines that clearly, so I'll be using a biro and from time to time a Sharpie to make it extra dark. Now, isometrics is, you would notice it from playing computer games such as Monument Valley or looking at the work of, say, Escher. An isometric cube starts off, we don't even need to bother about horizon lines or eye levels or anything like that, but it starts off with a kind of Y shape, which I've drawn here. Let's just get a cube in first of all. There's a Y shape at the top, a Y shape at the bottom, angle there, an angle there. So that should be right above there. So I constructed it out of light lines, light construction lines, and we're left with an isometric cube. Now, whereas in a perspective drawing that these lines that are going backwards would all converge at a single point, in an isometric we've got lots of parallel things going on. So that line, and that line are all parallel. Those lines are all parallel. Put that mark in there. And also those lines are all parallel. So you only ever have, certainly when you're drawing boxes and cubes, you only ever have three types of lines to worry about. The line which goes up and down, the line which goes that way, and the line which goes that way. That's the only three lines that we have to worry about in here. Now, those angles, this angle right here, is not arbitrary in an isometric drawing. That's a very special angle. And if you had a set square or a protractor, that angle should be 30 degrees. But since we're sketching without instruments, we have to guess what 30 degrees is. Now, there are two ways that you can remember this. 30 degrees can be remembered as approximately the time, which is 10 past 10. That's approximately 30 degrees in there. In fact, I think that's actually exactly 30 degrees on a clock face. So if it was 10 past 10, or 10 to 2, I suppose, then those angles would be 30 degrees. Or the other way to do it is do that with your finger and thumb, and pretty much that angle in there is 30 degrees. That angle right across there. So those are two ways that you can guess about what 30 degrees is. Now, let's draw that cube again. The cube starts off by us drawing the front edge, and then we send back lines at 30 degrees. Let's use our little gauge to try and work out what that is. Okay, it's about there. Parallel, there's no convergence or divergence of these lines. They don't meet in the distance, they just stay parallel like train tracks. And that is a cube drawn in isometric projection. Let's darken this up because there's other things I want to tell you about this cube, particularly the cube, which you may find useful, slightly advanced. Now, if it is a perfect cube, in other words, if it is a cube that has all of its edges the exact same length, then what you'll notice is that this point, at least on the paper, this point and this point are directly over one another. You'll also notice that it being a perfect cube and with these angles being 30 degrees, it just so happens that the outside shape is actually a perfect hexagon. So a shorthand way sometimes that I use to build a cube is actually to start, because I can, with something that looks like a perfect hexagon, which I simply just fill in the middle of. And that is basically isometric. So let's practice drawing some different bits and pieces. Let's practice drawing a nice tall box. So again, let's put in a tall line like this. Send those lines back 30 degrees and 30 degrees. Keeping everything nice and light. 30. Now at this point, I'm actually going to build my squares properly with my little rectangles properly with little diagonals. This is a good habit to get into, because when we start to add circles and we start to draw circles and curves in isometric, these lines start to come in handy. Let's darken up. It's worth going ahead and looking at some of the work of MC Escher. He not only drew a lot of paintings, a lot of rather famous paintings in isometric format, but he discovered that, in fact I'm not sure if it's him that discovered it, it may have been someone like Roger Penrose, but they discovered that there is an inherent optical illusion within isometric cubes. Now I'm not going to explain what that is right now, just go ahead and look for work by Escher and you'll soon see what I mean. But for me, isometrics are a lot easier than perspective drawings. You may find likewise, or you may actually prefer perspective drawings. So there's how we draw boxes of different shapes and sizes. Let's try one. Let's try a long, thin box. Okay, so let's put in our front edge, send our lines back at 30 degrees or thereabouts. Like I said, I prefer isometrics because it's less faff. You don't need a horizon line. You don't need vanishing points. You don't need to worry about lines all going in different directions. There's only 3 directions really that you need to worry about. And as we'll see, when you start to add curves and circles to these boxes, again I find isometric easier to do. But isometric, although it's an approximation of 3D, it's not the way a 3D object would look in real life. For that you would have to go and do 2-point perspective. Just put in my halfway markers, my little cross. Again, I'm not really going to make use of them just now, but it's a good habit to get into, because later on we'll be looking at circles and ellipses in isometrics. What about if you had to make a more complex shape? What about if we had to make an L shape out of boxes? Well, let's put in that front one like this. Send our lines back at 30 degrees. Now before we darken this, let's put a box right beside it. Let's put a box right beside it. There's our middle line. Let's send the lines back at 30 degrees. Make sure everything's parallel. Now you can see that we've built an L shape from using boxes and tall cubes. Let's just darken that up. Now in the perspective videos, we finished off by showing how to make things see-through in perspective. We'll do the same with isometrics, how you draw the back face and denote it with hidden line. But that intrinsic optical illusion problem, which was exploited by Escher and Roger Penrose, starts to affect us now. So let's take a shape such as, well, let's do our L shape again. Okay, so let's put a long piece in here, send that back at 30 degrees. And let's send the L shape off in this direction this time. Keeping all our lines parallel, remember we only need to really worry about making sure that once we've picked a direction, that all the other lines that are going off in that direction are parallel to each other, and that lines meet at intersection points. So you can see just from the construction line there that I've started to think about the back edges, and I'll go in with blue here. I don't know if that shows up too easily, but I've started to think about lines that are in the back that I can't really see. So let's darken the lines that we can see. The lines, remember, we imagine reaching in to the 3D world of the paper, and we ask ourselves what lines could we physically touch with our finger. And once we've decided what those lines are, we darken them. In this case, I'm not bothering to darken the line between the two boxes here, because that would be a smooth blend. In reality, there would be no edge there, no line. Just one smooth surface all the way across. And then those back lines, let's try and, I'm not sure if this is going to show up so clearly, but let's put in dotted lines. I'll try and make them fat. Now, here comes the problem when you start to draw perfect isometric boxes, is that the front edge and the back edge are actually continuous. They're in the same place. So one obscures the other, and we could see that from our perfect cube earlier on. The back edge is obscured by the front edge. But nonetheless, isometrics is a quick and it's an easy way to depict 3D objects on a 2D piece of paper.